So let's start with this one. I lost track. This number maybe 3 or 4. A survey is conducted with 15 people. In which 15 people are asked how many books they read last year, and here's their answers listed in order. Okay, so the data set is ordered, so it makes it easy to compute some of these things by hand. But we could also put everything on your calculator, and I'm going to go ahead and do that just because I feel like that's the better way to compute some of these things. In this one, you're not asked to find like standard deviation, but you should never try to find the standard deviation, by hand or using a formula. You should have your calculator compute that for you. Okay, so we'll go through how to do this on your calculator, and if you want, we can also go through how to maybe double check or go through by hand. But what I want to do to begin with is put the data set into my calculator. So I'm going to hit Stat and then hit Edit, and that's where I have this list editor. So in L1, I'm going to put my data list as it appears. So I think that's 5 repeated ones. One, 2, 3, 4, 5. Yep. Oops. Okay, then 2, 3, some 4s, 10, and 23. Okay. Once I have all of the data into my calculator to compute stuff, right, all my statistics, I'm going to hit Stat, go over to the Calculate menu, and then on one variable statistics, I hit Enter. My list is in L1. I don't have a frequency list, so make sure that's blank. And then we hit Calculate. Okay, so the X bar is the mean, but I don't think that they ask for the mean here. First thing they ask for is the minimum, first quartile, medium, third quartile, and maximum. If I scroll down, those are the last things on my one variable statistics, right? That's my 5-number summary. Okay. So the min is 0, Q1 is 1, median is 3, Q3 is 5, that's the third quartile, and the max is 23. Okay, and some of these we could have read off, right? Like obviously you can see the minimum is 0 and the max is 23. Okay. The mode is the most frequently occurring number, and in this case, because it's a small enough data set, right, as I was entering them, I noticed that I had 5 ones. I don't have 5 of anything else. Okay, so 1 is the most frequently occurring data value, so the mode is 1. Okay, so remember, for the mode, we put in the data value, not its frequency. All right, range, we actually have to compute something. So range is going to be the max minus the min. Okay, so 23 minus 0 gives me 23. Okay. The mid-range is going to be halfway in between your extremes. So I'm just going to average the two extreme values. Okay, and again, that's not one that's built into your calculator. Okay, the inner quartile range is the range for the quartile. So the range, we took the max minus the min. For the inner quartile range, we take the bigger quarter, the third quarter, and we subtract out the value for the first quarter. So the inner quartile range is going to be Q3 minus Q1. Okay. So in this problem, they're giving you a box plot. Just as a refresher, if you wanted to create that box plot on your calculator, now that I have the data entered in, I could hit second and hit stat plot. make sure that it's turned on. And I'm going to go to the box plot. I want the first one that sort of has the 2 dots on the side. That's the box plot that will mark outliers. The other box plot that your calculator gives doesn't mark outliers. Okay, so then you can hit graph, but you won't see the whole thing. So we go to zoom and we zoom stat so that it will fit the entire box plot. And that should look like the box plot that we have here. Okay. So which values are outliers? If I'm looking at my calculator, I can see that this 1 dot out here is an outlier. And if I hit trace, I can go over to see what its value is, right? And it's 23. If I'm given a graph like this, I can see, well, I have 1 outlier. It's the biggest value, and I know that that's 23. Okay, suppose your friend, who doesn't usually read many books. So let's double check. How do you get the plot in the calculator again? As long as we have the data entered, right? So all of our data is in list L1. Okay. Then from our home screen, we can just hit second and then hit the y equals in order to get to the stat plots. Okay. So on stat plot 1, you hit enter, make sure that it's turned on, and make sure the type is a box plot if that's what you're trying to get. And then you can just hit graph, or I usually just hit zoom and number 9, so I jump straight to the properly zoomed graph. Okay, suppose your friend who doesn't usually read many books decides that they want to read more often. They set a goal for how many books to read next year. Which statistic would be most useful to them in deciding whether their goal is reasonable? The median, range, interquartile range, or mid-range? Okay, so if I have a data set that has outliers or is skewed, then a good way to measure the middle of the data set is going to be the median. Okay, so they should use the median as sort of a judge for how much to read. Okay. The problem with all of these other ones, range, interquartile range, and mid-range, and specifically the range and mid-range, the problems are that I'm really computing those using the extreme values, right? The range used the max and the min, the mid-range uses the max and the min. And when I have outliers, then those values are not going to be a good representation of my data set overall. Okay, I'm seeing who doesn't read and who reads, the absolute most, and making decisions based off that, and that's not a great idea. The interquartile range has a very different problem because it's not really telling me like an average or a middling number of books. It's giving me a measure of spread outness, and I don't want to use that when I decide how many books to read. Okay. All right. Any questions over this one? Okay, so let's go on to this next one. This next one is similar because we're going to be working with a data set again and entering it into our calculator. So here's data set 1, and I guess this gives you all the data sets when you click on it for like the whole test. But so let's go through and look at entering data set 1. And what I'm going to do is I'm going to go top down for each column, and I'm going to enter everything in. And this is a lot of numbers, and you can say, I'm really concerned about making a typo. So the first thing that I'm going to do is I'm going to show you how can you double check to make sure that you didn't make a data entry error. Okay, and I'm going to intentionally make one. The very last number is 46. I'm going to enter 47 for my very last value, and we'll just take a look at this. Okay, so what I'm going to do now to double check my data set and make sure I entered all 50 of those numbers correctly. So I'm going to hit stat and I go over to calculate one variable statistics, okay, L1, frequency list is blank. and I hit calculate. And it says on here, if you enter the data correctly and you run one variable stats, then this sigma x squared thing will be 52,304. And mine is not. I know that I entered at least one data value incorrectly, and I have a different number here. I have 52,397. Okay, so if this number doesn't match exactly, then you have an error. Okay, so I go back, stat edit, and I go through the whole thing. Now I intentionally made this last one wrong, so I'm going to fix that, and let's see if I did anything wrong on accident. So stat calculate one variable statistics, and now I have 52,304, just like I'm supposed to. And that's sort of my like double check to make sure I entered all of my data values in correctly. Okay, so if this number matches, then it's very, very likely that all of your numbers are exactly entered correctly, and then you can move forward, and you don't have to worry about getting a wrong answer because your data is incorrect. Okay, and all of the data sets that you have will have that check on there. Okay, so you can make sure that you aren't making any typos as you go. All right. The question is to first find the mean and standard deviation. Okay, so in this one variable stats, the x bar is the mean, so 30.48. And then for standard deviation, you have to be a little bit careful. Remember, your calculator gives you two different values for standard deviation, this Sx and this sigma x. And they're going to be close to each other, but they're not the same. And they use different formulas based on whether or not you entered in a sample or a population. Okay? And you should just always assume, unless you're very specifically told, assume that you are always working with a sample. So we want the S value. Okay? So if I want to round to 3 decimal places, that will be 10.929, because I'll round that 8 up. Okay. Now, in order to create a grouped frequency distribution, I find it easiest to have my calculator do the work, because that was a lot of data values. And I think that the easiest way to have it sort everything is to create a histogram. So let me show you how to make your calculator compute the correct histogram. So what I'm going to do is I'm going to hit second, and I'm going to hit stat plot. Okay, I'm going to make sure the stat plot is turned on. And this time for type, I want to select the histogram. Okay, my X list is L1, and frequency is just 1. I can't leave it blank here, but the idea is that the frequency is just telling you, for the stuff in L1, how many times do you want it repeated? I just want it once. Okay, I don't know anything special there. Okay, so now if I hit graph, it's going to be all wonky. So again, I should just get in the habit of hitting zoom and stat zoom, or sorry, zoom stat. Okay, so that'll make it fit on my screen, but I want 5 groups, and my calculator has defaulted to 8. Okay, so the way that I can get my calculator to fit right is to hit the window. Okay, now I want the first group to start at 0. So I'm going to make my minimum value 0. Okay, and then for the scale, that's where I put in how wide I want the bars to be, or the groups. And since the next one starts at 12, okay, they're spaced 12 apart, right? 0 to 12 is 12 distance, right? 12 to 24 is 12 distance. So for my X scale, I want that to be 12. Okay. And now I go back and hit graph. And in this case, because I've clumped them together, some of the bars are a little bit too tall. So I can change it one more time. I can make my Y values go higher, my Y max. Okay, so let's make that go up higher. I'll just pick 20, take a guess, and then that fits. Okay, so to outline the steps again, first step was to enter the data. Okay, so we hit stat, and we went to edit. Okay, Then we check the data. So we hit Stat, went to the Calc menu, and press that one variable stats. Okay. And now we're going to create the histogram. So we hit our second button, and then we hit the Y equals button to create a stat plot. Okay. Okay, then we need to adjust. So you can start by hitting zoom, and then you can hit 9 for zoom stat, or stat zoom. I forget which way it goes. But then we also typically have to adjust the window. Okay, so we want x min to equal the start of our first group. And we want x scale, xscl, to equal the width. Okay. And the width is not from 0 to 11, it's from 0 to the start of the next one. Okay, so from start to start. Okay, and then you hit graph. Okay, so now the way that I use this histogram to fill out my frequency distribution is when I hit trace, it will count, right? So in the first one, it says that there is 1. Okay, and on the next bar, from 12 to less than 24, so 12 to 23, it says there's 13. Okay, then 19, and 13, and then 4. Okay, that doesn't give me the relative frequency. Remember, relative frequency is just taking those frequencies and turning them into percentages. So we know that we had a total of 50. We could have also seen that when we press that one variable stats, it counts it up, or you can add up the frequencies. Okay, but we have a total of 50. So to get the relative frequency, I'm just going to take each frequency and divide by 50. So 1 over 50, 13 over 50, 19 over 50. Right, and so on. Okay, so 1 over 50 gives me 0.02. Okay. 13 over 50 will give me 0.26. 19 over 50 will give me 0.38. 13 over 50 again. And 4 over 50 will give me 0.08. Okay. And as a double check, if I add up my relative frequencies, okay, again, if I think of them as being percentages, if you add up all your pieces, you should get your whole, right? So you should get 100%. So I add them all up and I get 1, which is 100%. Okay, so that's how I can double check my relative frequencies are correct. Okay, the graph above shows a frequency histogram for these data. According to the histogram, does this data look approximately normal? Why or why not? Okay, so what I would do is I would say this histogram is bell-shaped and roughly symmetric. So it looks approximately normal. Okay. Now, a quick note, when you're doing the practice test, it's never going to grade this because this has to be manually graded. And the practice test, people just kind of take over and over again, so that's never getting manually graded. You can always, email me if you want to see if your answer is, an acceptable answer or anything like that. On the actual test, when you take the test, this will be marked wrong, right? If you have anything like this where you type something in. After the due date, so the due date is on Wednesday, so on Thursday I'm going to go through and grade them manually and make sure that, then that's when you'll get your points. So when you first take the test, that'll be marked wrong. Then the next day when I grade them, that's when the points will come back. So don't get too hung up on your test grade immediately, right? You're going to be getting points based on not just like this question, but anything like this where you have to type something in. All right, any questions on this one? Well, good. All right. Is there any other one that in particular that you guys want to look at? I don't know if we have enough time to go through like the whole thing. No fallacies. That we'll go over when we study when we start reviewing for the final exam. Then that's when we have to worry about going back to old units, and then we'll worry about logical fallacies and stuff like that. So this is just the stat stuff, yeah. I want to look at this question really quickly. If nobody has something that you in particular want to do. And again, my motivation here is to make sure that we're using our technology correctly. I don't want people to feel like, okay, I understand the concepts, but make a mistake navigating your calculator or something like that. All right, so this one says data set 4 on the data sheet shows a frequency table for the number of children in 200 randomly selected households in a certain city. So what this is telling me is that I have a sample of size 200, but I'm not going to actually enter 200 individual values on my calculator. So if I, look at the data sheet, it's given to me as a frequency distribution, not just the, raw data. Okay. For showing your, okay, so that's a good question. How would you like us to show our work on the test, since most of it will be on the calculator? Like a question like this, yeah, we're going to put things onto our calculator, so there's not a whole lot of work to show. Okay. If you want, like on your page, you could write what symbols you're reading off of there. So like on my Scratch page, and we'll go through this when I get something, but I would write down, okay, for the mean, that's X bar, and then I write the number, the standard deviation. And on my calculator, that's going to be the SX1, and then I write down the number. So that way you can at least show me that, what you're putting down. And that way I have some way to follow along, especially if something is incorrect. Okay. Okay, so let's look at getting this data onto my calculator. So here's my data set number 4. So on my calculator, if you would like, I'm going to show you how to do this, not putting everything in L1 and L2, right? So maybe I want to put this in the values in L2 and the frequencies in L3 or something like that. Okay. So I'm going to start by putting my actual data, the values in one list, right? In this case, L2. Okay, so I have the numbers 0 through 7. And then in L3, I put the frequencies that correspond to each of those values. Okay, and then once again, what we're going to do is we're going to run a check. And I'm going to first show you this incorrectly. I'm going to make a different mistake than last time. So I'm going to hit the stat button. I'm going to go over to calculate one variable stats. And this time I'm going to say I didn't put the data in L1, I put it in L2. Say, okay, great. And I hit calculate, and I look at my sum of x squared, 140, and I look at on here, and it has 1,511. I say, oh, that's a mistake. But when I look at my data, it's just 0, 1, 2, 3, 4, 5, 6, 7. That's absolutely correct. And when I look at the frequencies, those are all correct too. So what went wrong? The thing that we have to be careful about here is that I don't just have 8 values, right? I don't just have the numbers 0 through 7. They are repeated values, and I need to let my calculator know that. So when I hit one variable statistics, what I want to make sure I do is I say the list is L2, and I have a list of frequencies. So I have to tell it the frequency list, L3. Okay. If you have an older calculator, like a TI-83 or something like that, when you hit one variable stats, it just pops one variable stats up on the screen, and that's it. What you need to do is say, if I only have one list that I'm looking at, okay, I hit second and I put that list. If I have a frequency list, okay, I'm going to put comma, and then I hit where the frequency list is, in this case L3. So my data is in L2, comma, the frequency list is in L3. Okay. And now when I look at my sum of x squared, it's 1,511, sum of x squared, 1,511, and I say, good, everything checks out. So now I have everything entered correctly, and my calculator knows exactly what's going on. Okay, so then my x bar is the mean, 2.335. Standard deviation SX is 1.4537. Okay. When I go to type this in, it says round to 3 decimal places, so that's where I'll do some rounding. In this problem, they don't ask for, oh, forgot to do my rounding. They don't ask for variation. If you want the variation, remember that's squaring the standard deviation, but you want to use all of the decimals if you're going to do any squaring. You don't want to round and then square. Okay. To get the median, I go down and read that off my calculator. The median is 2. Okay. The first quartile is Q1, that's 1. Third quartile is Q3, that's 3. Okay. So again, looking at my raw data here, it can be a little bit confusing because you're like, isn't the median like, shouldn't I be averaging 3 and 4? Shouldn't it be somewhere in there? Okay. Remember, I have this frequencies. I have a lot of 0s and 1s and 2s and 3s. I don't have very many 5s and 6s and 7s. Okay. So the middle value actually occurs much earlier. Okay. For the mode, I want to look at the data value with the highest frequency. And here, the highest frequency is 52. So the mode is 2. Median was on the calculator, yeah. So the calculator gives you the min, Q1, median, Q3, and the max. So things that you have to find out on your own would be like the mode, right? But you don't you could just look at the frequency distribution to see the mode, okay? Things that you have to compute on your own would also be like the range, They didn't ask that here, but we did that in the last problem. The interquartile range, again, we did that earlier. But there's not very many of those. All right. I think we have time for one more. Maybe let's do, so this one has lots of parts to it. It's sort of the latest stuff that we did. So I think it's probably the most complicated. And here's where we're going to be able to show a little bit more work, I think. Okay, a high school guidance counselor has a pamphlet that says that 20% of all high school students go to a community college after graduation. In a survey of 150 randomly selected high school seniors, so what I'm going to do as I'm going through is I'm going to say, okay, the information that I'm given in the paragraph, I have 150 randomly selected seniors, so my sample size is 150. Okay. So in that survey of 150 randomly selected seniors, 43 replied that they plan to go to community college in the fall. So that's how many replied yes. So X is 43. And, I could maybe make a side note. This is the number of yeses to my question. Okay, use a 95% confidence interval to test and see if the pamphlet needs updating. Okay, the pamphlet says that it's 20%. Okay, so we want to test to see if P is equal to 20% or 0.20. So that's what we're doing. Okay, the first thing that we're asked to do is which of these facts would tell us the pamphlet needs to be updated. Okay, so what we're doing is we're saying, well, what is it that will actually answer my ending question, right? How do I know, what the answer is going to be? What is it that I'm looking at? Okay, so if the sample proportion is different from 20%, if in the population the proportion is actually 20%, when we take a sample, we know that samples have a little bit of variability to them, right? There's some randomness when you're selecting people. So even if the population was exactly 20%, I know that in the sample I would usually get something slightly off from that. So that sample proportion being different from 20% isn't enough to tell me that the pamphlet needs updating, right? That the population proportion is different. Okay. If an appropriate confidence interval does not contain the sample proportion. When I create a confidence interval, that gives me a range of values that I'm very confident will contain the actual population proportion. The confidence interval doesn't tell me about the sample proportion. Okay, and in fact, sample proportion is always in the dead middle of the confidence interval. So this is just a bit of a red herring there, because the confidence interval will always contain the sample proportion. It's not the sample proportion I'm looking for. Okay, if the sample proportion is the same as 20%, no, what we're really looking at is the population proportion. That's what we want to know about. All right, if an appropriate confidence interval contains the sample proportion. Well, again, just like this earlier one, whether the confidence interval contains or does not contain the sample proportion isn't telling me about what I want. I want to know about the population proportion. Okay. Also, confidence interval will always contain the sample proportion. Okay, if an appropriate confidence interval contains 20%. Now we're getting to something. We're testing to see if the population proportion is 20%. And the confidence interval will give me a range of values based on the data I have that I can be confident that the population proportion is in. So if 20% is inside my confidence interval, then that's a reasonable guess for what the actual value of the population proportion is, the actual percentage of high school students that go to community college. Okay, so if 20% is in there, then 20% could be correct. And if that's the case, I don't need to update the pamphlet. if an appropriate confidence interval does not contain 20%, then I know that pamphlet must be wrong. So this is the one I'm looking for. Okay. So in this case, the pamphlet must be wrong. Because the pamphlet says it's 20%, and if the range of values that I'm sure that the confidence, that I'm sure that the actual percentage is inside doesn't contain 20%, then 20% is definitely wrong. Okay, in order to use a confidence interval to test whether the pamphlet needs updated, what conditions must be checked? Okay, so what we need are that the population is big enough and that the sample is big enough. And what we use to check those, okay, is the three checks we had were that NP hat was greater than or equal to 10, N times 1 minus P hat was greater than or equal to 10, and capital N is bigger than 20 times little n. And once again, I think that if you just look at these as a list of three formulas, then it's really confusing. What we're doing is we're using these first two to make sure that the sample is big enough. Okay, and in particular, n times p is equal to x, which is the number of yeses. The n times 1 minus p is equal to the number of no's. Okay, so when I'm doing my checklist, total population needs to be at least, no, that's not right. I'm not looking at the total population here. And little n isn't the total population. Okay, the number of students who said they plan to go to community college who answered yes to my question, NP is equal to 43, needs to be at least 10. Yeah, that's my first condition. NP needs to be at least 10, right? That's the number of yeses. Okay. 20% of the sample, NP is approximately 30, need to have said yes. No, that has nothing to do with what we're checking. Okay. The total population of all high school seniors needs to be more than 20 times little n. That's what this third condition is saying. The capital N is my population size. Okay, and it's saying that needs to be bigger than 20 times little n. And little n we said was 150. Okay, 20 times 150 is 3,000. Okay, so my population size needs to be bigger than 3,000. Total population of all high school seniors needs to be more than 20 times little n, which is 3,000. Yes, that's my third condition. Okay, so I'm still looking for the second one. 100 minus 20% of the sample, n times 1 minus p is approximately 120, needs to be at least 10. There's a lot of words in here that sound like stuff that we have said that are jumbled together in a different order. Okay, so correct words in the wrong order does not make a correct sentence. Okay, the number of students in the sample who said no, they do not plan to go to community college. That's what this n times 1 minus p hat is. Okay, if 150 plan to go to community college, then if 150 total people I asked, if 43 said yes, then 150 minus 43 is the number that said no. Okay. So n times 1 minus p hat is 107. That's what we said. And that needs to be at least 10. Yes. Okay. 20% of the sample. Again, we're just kind of picking numbers that we read in the paragraph and putting them together in a weird order. That's not correct. 20% of all high school seniors needs to be at least n equals 150, right? That's not anything that we need to check. Okay, 100% minus 20% of the sample, n times 1 minus p equals 120. Need to have said no, they do not plan to go to community college. Okay, once again, This is close. We're taking a lot of the right ideas and we're mixing a lot of different correct ideas together to form a wrong idea. Okay, so that's not one of the, we want these three. All right, what proportion of high school students surveyed plan to go to community college in the fall? All right, if I look at the amount surveyed, I surveyed 150 and 43 said they plan to go to community college in the fall. Okay, so here what I would write down is I would say, you know, p hat, that's the percentage of my sample, is 43 divided by 150. Okay, and if I just divide that, I get 0.28666 repeating. And if I round to the nearest tenth of a percent, well, I want to write it as a percentage, so I move the decimal over twice. So that would be 28.66. And if I then round that to the nearest tenth, that would be 28.7%. Okay, everyone still with me so far? Let's hope so. Based on the sample, use your calculator to construct a confidence interval. Okay, now it said back here I'm using a 95% confidence interval, so that's the confidence interval I'm going to compute. So what I'm going to do is go to my calculator and press stat, go over to tests, and I need to go down and select one prop z int. Okay, and it asks me to enter the x, the n, and the c level. So again, if I'm writing this down on my page to submit for Scratch work, say, okay, the x that we said was 43, the n is 150, and the c level is 0.95. So then when I hit calculate, I get, and I'm going to write this down on my page, I get 0.2143, comma, 0.35903. On my screen, it's asking me to enter this as a percent rounded to the nearest tenth. So to convert to a percent, I move the decimal over 2 places. So I'll have 21.43%. And then rounding to the nearest tenth of a percent, I say, okay, I want to round to 1 decimal place, so 21.4. Okay. The second number will be 35.903. I do the same thing. I want to round to the nearest tenth of a percent. Okay, so because it's 0.90, it's going to round to just 9. So 35.9. When I look at this confidence interval, 21.4% to 35.9%, the 20% that we were testing for is not in the interval. Okay, if I were to write this on a number line, so here's my 21.4%. Oops, here's my 35.9%. The p hat that I got, I know is going to be the dead center. Okay. The thing that I'm testing for, though, is that 20%. 20 is smaller than 21. So my entire confidence interval lies to the right of the thing I'm testing for, to the right of that 20%. So the sample proportion is the same as 20%. That's not correct. The confidence interval is entirely to the right of 20%. Yes. The sample proportion is different from the 20% shown in the pamphlet. That's correct, but that's not important. The confidence interval we found contains 20%. No. Confidence interval is entirely to the left of the 20%. No. Okay. So because 20% is not inside my confidence interval, I know the 20% is incorrect, which means that the pamphlet should be updated. So should the pamphlet be updated? Yes. So I'm going to pick one of these ones that says yes. And it's because the confidence interval doesn't contain the 20%. Okay. So what does that mean? That means that we have evidence that that percentage of high school students that will attend a community college is more than 20%. So I kind of like the wording on this one, except that it's saying no. It should be yes, because we have enough evidence to conclude the sample proportion is now different from 20%. Okay, and I think that this is the one that's closest to actually saying that. Should the pamphlet be updated? Yes, because we're 95% confident that the population proportion is now different from, and in fact bigger than, 20%. Okay. I think that gives us everything on there. All right. Any questions on this one? All right. Well, again, if anything pops up, if you have any questions, feel free to email me or drop into office hours. The test is due Wednesday. Yep. We will not have regular class tomorrow. Just finish up homework if you're doing any of that late. Go through the review if you still have that to do, or you can take the test tomorrow. But yeah, we won't have regular class tomorrow. And remember, you can always pop into this same meeting to during office hours to get help, or email me to schedule a time outside of my office hours. That's fine too.